Okay, so what if A is negative? Welcome back, by the way. What if A is negative? What do you do about that? Well, I'm going to show you a couple of examples of what that might look like and how easy it is to fix that and render it so that we go back to the same process we've been doing before. So here's the first example I'm going to give you, and this is related to your book example 3, and it looks like this. 22 added to 5p minus 3p squared. So here's the ax squared portion, here's the bx portion, and there's the c portion. So first thing you're going to want to do is arrange it so that it goes back to this pattern, which would make it negative 3p squared plus 5p plus 22. We just rearranged it, okay, in decreasing degree of a. Next thing you're going to do is you're going to factor out your negative 1, okay? If I pull out a negative 1, that makes everything else here the opposite of what it is. 3p squared. So the opposite of negative is positive. Negative 5p. The opposite of positive is negative. Negative 22. So we factored out the negative 1. Okay? Once you do that, you're going to be able to maneuver your trinomial in the same way we've been doing before. So, and this is going to rejoin whatever your end result is in the factoring. Okay, don't forget to include that in your answer. But in the meantime, factors of AC, which is negative 66, that have a sum of negative 5. So 1 and 66, 2 and 33, 3 and 22. None of those seem to work. 5. So how about 6 and 11? 6 and 11. In order to make this a negative, one of these has to be positive, one of those has to be negative. If I make the 11 the negative, then not only do I get a negative 66 as my product, but their sum then indeed, because that's a bigger number, results in a negative 5. So that's your factors that you want to use. Pull down your first item and your last item. Neighbor these next to what you think they best factor with. Obviously the 11 will group quite nicely with the 22. Negative 11. Don't forget to add the variable. The above one happened to have the 2 variables from yesterday, but this one is just a single, just like the normal ones. And that 6 is positive. Group, pull 3p out of here. So that's 3p, p plus 2. Negative 11, p plus 2. Remember, your goal is that these two things are the same. If you would have pulled out a positive 11, you would have had a negative p and a negative 2, which doesn't match that. So you got to make sure you pull out the right thing so that this matches that. Otherwise, you won't be able to group. So I have 3p grouped with the negative 11 because both of those get multiplied by p plus 2, and the negative 1 joins the party. That's your end result. Okay, so when you have a negative quadratic, that's the squared term. That's how you handle that. Factor out your negative 1 first. Let's try and see if I have another negative real quick. So how about 1 minus 5b minus 8b squared. We're going to rearrange it so that our square is first. Negative 8b squared minus 5b plus 1. So we rearranged it. Then we're going to factor out our negative 1. Negative 1, positive 8b squared, positive 5b, negative 1. Remember what I was saying, that when you pull this out, it flips everything within. So, factors of 8 times negative 1, negative 8, with a sum of 5. 1 and 8, no. 2 and 4, no. Guess what, folks? There is nothing that can be done with this polynomial. This polynomial, other than pulling that out, is known as prime, because nothing exists that would satisfy the necessary components that would lead us to a factor. Your answer to this would be prime. Dun, dun, dun. All right, I'm going to do one more negative that's actually factorable. An example 4 in your textbook is just a harder one, and I'm not going to stress out too much about that. But here, we'll do this one. 7 minus 12s minus 4s squared. Rearrange it so that your s squared, your quadratic, is in the first position. Factor out negative 1, which flips the signs of everything. The negative 4s squared becomes positive. The negative 12s becomes positive. The positive 7 becomes negative. The negative 1 will rejoin the factor at the end. Meanwhile, factors of a times c, which is negative 28, that have a sum of positive 12. So let's see. 2 and 14 looks like it'll work, doesn't it? Negative 2 and positive 14. I chose it to be negative 2 and positive 14 because either way will make a negative, even if that's negative and that's positive. But only with positive 14 and negative 2 will you have a sum of positive 12. There's your numbers. Bring down your first and last component. I'm going to put the 14 next to the 7 with the s, and the negative 2. Group. Out of this, I'm going to pull 2s, s minus 1. And here, I'm going to pull out a 2s minus 1. I'm going to pull out a positive 7, because then I can have 2s minus 1. Remember, what you pull out of that second piece has to force this to match that. Otherwise, you can't group these items together. So negative 1, group your 2s and your 7, and 2s minus 1. There's your answer. And like I said, you can look at example 4 in your textbook. It's just a harder one mathematically. But with practice, you'll be able to quickly find those factors. And sometimes I have to look at my calculator, of course, and see what kind of numbers I can come up with. But for the most part, it just takes time. I will let you have the rest of this time to yourself.